Adaptation to the environment is a complicated subject. Physiologically, we can approach adaptation in terms of an interaction between the living system and its physical environment. Two attributes of the physical environment are extremely important in this regard: temperature and moisture, both of which are extremely variable and pose considerable adaptive challenges. For example, temperature affects the thermodynamics of all chemical and physical processes, both living and non-living. That's the whole point of the concept of the thermodynamic temperature, after all. Biological function is marked by persistence. Living systems have to persist no matter what temperature is doing to its biochemistry. Adaptation is the reconciliation of this persistence with environmental variability and unpredictability. For the next several lectures, we're going to be dealing with how this reconciliation takes place. In this lecture, we're going to look at the thermodynamics of temperature and set it into a mathematical context that will allow us to analyze the physiology of adaptation to the thermal environment. We're going to outline the concept of the energy budget, and we're going to talk about how different types of animals exist within this fundamental physical constraint. We're going to talk about the nature of adaptation as a manipulation of physical fluxes of heat by organisms. We're also going to explore some long-standing problems in biological adaptation and recast them in a way that both makes more physical sense and that undermines some hoary biological myths. As you watch the videos to follow, I want you to keep four things in mind. What is temperature, and what is its meaning for physiological function? What is the nature of temperature adaptation, and how can we analyze it physically to make sense of this essentially biological phenomenon? Why should it be that selection on temperature adaptation should have driven animals into two very distinct forms of body temperature lifestyles? This question is similar to the one that I posed elsewhere with respect to selection on energy lifestyle. This is more than simple analogy. The two are tightly linked. And finally, I'd like you to reflect on how long-standing misinterpretations of thermal adaptation can be cleared up with a fresh and more rigorous analysis of the phenomenon. I'm speaking specifically here of the long-standing problem of Bergmann's rule. You'll see what I mean when you get to those lessons.